Hi, my name is Kelly Williams, and I'm the Director of Engineering for Eaton Aerospace. Welcome to 10 and 10, the podcast exploring the future of aerospace innovation. Today's topic is electric flight in military and defense applications, how electrification can transform surveillance, logistics, and operations. Joining me today is Dr. Armen Baronian, the Director of Advanced Technology at Eaton's Aerospace Group. So let's dive into how these technologies are shaping next-gen electric aircraft. So Armen, I would like to kick things off by getting your thoughts on how electric propulsion can enhance military surveillance and reconnaissance missions.
Thanks, Kelly. I think that electric propulsion enhances military surveillance and reconnaissance, but by providing significant quieter and stealthier operations, which is crucial for undetected movement and data gathering. It also reduces thermal signatures, making vehicles and drones less visible to infrared detection. I think that additionally, electric vehicles, in other words, aircrafts, reduce reliance on vulnerable fuel supply chains, lower logistical burdens, increase operational flexibility with features like exportable power, and can even enable more sophisticated autonomous operations. So on the other hand, Kelly, could you share, please, your insights on the topic and your perspective on what do you think that the strategic advantages of electric aircraft in defense logistics would be?
Sure. There are several advantages for electric aircraft in defense, including their ability to operate in remote or difficult to access locations. They have a low sound profile, and they have a potential to reduce the costly use of large-scale cargo haulers or rotorcraft that we use today. They're also more cost-effective to deploy and to maintain, and they're also electric in nature, so it aligns with the military's commitment to both sustainability and net zero energy goals. So talking more about that, Armen, could you share your thoughts on how electrification can impact the stealth, noise, and heat signatures for military operations?
The key characteristics that I think contribute to enhanced stealth in electric military vehicles include their ability to operate with a significantly reduced acoustic signature, as electric powertrains generate far less noise than traditional combustion engines, making detection by enemy forces much more difficult. And additionally, these vehicles produce a lower thermal signature, emitting less heat and thereby reducing infrared visibility, which much complicates targeted by surveillance systems. Many designs also emphasize compact and efficient construction using some of the lightweight materials and streamlined shapes that are improving both stealth and maneuverability across diverse terrains. So, and just to continue, Kelly, in your opinion, what's the key insights on what are the unique durability and reliability requirements for military aircraft nowadays?
So the defense market has been shrinking, but we have seen expansion in the commercial electronics sector. And that's really led the Department of Defense to ease restrictions on using commercial grade electronics for military systems. Even though we're doing such, there are questions that remain about the ability to deliver the durability and the reliability in the harsh environments over the extended periods. So Eaton's been leveraging its aerospace expertise and its electrical sector knowledge in order to meet the stringent military standards required for safety and efficient aircraft operation. So these standards are really critical for us in designing and testing power solutions to make sure that our converters, our stabilizers, and our power supplies can perform reliably under variable conditions without failure. So Armen, for our listeners, would you mind explaining your perspective on how the defense sector is approaching autonomous electric flight?
The aerospace and defense industry is undergoing a major transformation with the rise of autonomous systems from unmanned aerial vehicles to AI-powered aircraft, fundamentally reshaping aviation, defense, and global security operations. These technologies deliver increased efficiency by performing tasks faster and with greater accuracy than humans, while significantly reducing risk by limiting human involvement in dangerous missions, thereby saving lives. Furthermore, automation drives cost savings through lower labor expenses and improved operational efficiency. AI-driven data analysis also enhances decision-making, enabling more informed strategic planning and also rapid responses to complex scenarios. I hope I answered your question, and in return, can you please let us know and our listeners what's the most important point you think people should take away about what are the main challenges of deploying electric aircraft in combat or remote environments?
Yeah, that's a great question. There are a number of big challenges that we need to overcome in order to use electric aircraft in remote environments. So we talk about battery technology. It's still quite heavy and it lacks the energy density of fuel. So there are limitations in its performance. And hence the range and the endurance are shorter. So it makes the missions harder to sustain. Then there's infrastructure. So there is a concern with aircraft relying on more electronic systems and charging stations in remote and contested areas. They just don't exist today. And with that, there are growing concerns with cybersecurity. So with aircraft relying more on electronic systems, they're more vulnerable to hacking or electronic warfare or GPS jamming. So that's why secure architecture, encrypted networks, and defense in-depth strategies are really critical. So companies like Eaton are already looking at embedded cybersecurity into our power systems using AI-driven threat detection and global compliance standards so our aircraft can still be mission ready. So the bottom line is there are a lot of challenges that we need to undergo and resolve, and therefore we need to continue to invest in our R&D before electric aircraft can really operate in these demanding environments. So we talked a little bit, Armen, about unmanned aerial systems. How do you see electric aircraft fitting into the future of unmanned or aerial systems?
Yeah, thanks, Kelly. Definitely the future of aerospace and defense is autonomous, in my opinion. And over the next decade, A-powered systems will drive fully autonomous aircraft and next generation drones. Today, we have manned platforms that dominate due to infrastructure and familiarity, but that's changing. Electrification is accelerating this shift. Hybrid and fully electric aircraft, manned and unmanned, they all offer energy efficiency, better control, stealth, and lower maintenance. A prime example is the Collaborative Combat Aircraft, so-called CCA concept, which is a part of the Next Gen Air Dominance program, which pairs manned and unmanned systems for air superiority. These unmanned platforms will be highly electrified, that's for sure. And then the following question to you, Kelly, is in your view, how do you see that role electric aviation plays in humanitarian or maybe disaster relief missions?
Yeah, I think it has the ability to play a very critical role, actually. Using electric aviation, we can enable more rapid transport of things like medical supplies, food, volunteers, really swiftly evacuate or transfer patients in a timely intervention in order to help save more lives. With drones and advanced aircraft, we can enhance operational efficiencies and provide real-time video surveillance and deliver essential supplies in hard-to-reach areas. So if you think about roads and traditional transport linkages that could be damaged or destroyed, aviation can bridge that gap by allowing us to ferry emergency resources directly into isolated regions. So another question for you, Armen. How do you think the military is investing in R&D for electric propulsion technologies?
I think that the United States has taken the lead in advancing electric propulsion systems for aerospace, marine, and military applications, driven by decades of NASA research, private innovation, and government investment. Starting with NASA's, if I remember, deep space electric propulsion work in the 60s and early breakthroughs in the 70s, culminating in a 30 kilowatt arc jet system in 1999, the momentum accelerated in the 2000s as private firms adopted electric propulsion for satellite positioning, for example. I think that today the US military actively funds research for electric aircraft and ship systems, basically recognizing the benefits in stealth and definitely efficiency as well. And the last question for you, Kelly, what would be your take on what are the implications of electrification for now longer range and high-speed military aircraft?
Sure. Yeah, we talked a little bit about some of the benefits of electrification, like improving the military's stealth by lowering the acoustics and the thermal signatures. We talked a little bit about challenges, and one of those being the battery energy density is still a barrier for long range and high speed missions. So hybrid electric propulsion is a solution, a practical solution that blends both the fuel and the battery power to optimize energy use and enhance mission flexibility. So electric propulsion is already proven in space. We already use it today for station keeping, orbit raising, and primary propulsion for military satellites. So its efficiency is really suited for long duration missions. So overcoming the battery limits that I talked about for extended flight requires a multidisciplinary approach. So Eaton's been advancing power electronics, distribution systems, and thermal management in order to enable that next generation electric military aviation.
Yeah, I would like to conclude by saying that electrification is definitely reshaping terrestrial and aerial vehicles to cut greenhouse gas emissions. Military operations reliant on energy must adapt even as traditional fuels outperform batteries in energy density. Advances in batteries, hybrids, and biofuels offer viable solutions. Electric military aircraft reduce emissions, noise, and heat signatures, boosting stealth and safety. Commercial progress accelerates defense adoption. Despite challenges that we have, electric aircraft promise cleaner, quieter, and more efficient operations. Thank you.